Hello and welcome back to Mr. Powers Teaches Algebra. We're still doing word problems, and this time I wanted to do a problem I always found really fun. When I learned how to do these problems, I was in middle school, I think, and it was just a really fun problem because for some reason I had difficulty with it. And anytime I have difficulty, it's fun for me. Okay, so they're not so difficult anymore, but again, I've gotten better at them. I've done a lot of them now. You know how it goes. So let's take a look at this. Now we call these problems, some books or collection of notes might say work rate problems. They might say work rate. Is that what I'm doing? Yes, I'm doing a work rate problem. Okay, and these are just the way they're worded. It just throws people off. So let's go for it. An office has 2 envelope stuffing machines. Machine A can stuff a batch of envelopes in 5 hours, while machine B can stuff a batch of envelopes in 3 hours. How long would it take the 2 machines working together to stuff a batch of envelopes? And so, if you want an experience like I had in middle school, I'd say, hey, try to solve it right now with all the strategies you got so far. Go ahead. Do it. And you get a weird answer. And I tell you get a weird answer because it's very intuitive what the answer is going to be. If one machine can do it in 5 hours and one machine can do it in 3, how long would it take working together? Well, I'll just tell you right now. Those slow ones, 5 hours, right? And if there were 2 slow ones, it's an easy answer. They can do it in half the time. If there's 2 of these machines and they go at the same rate, they can do a job in half the time. So the answer is not more than 2.5 hours. We know actually it's going to take less than that because this second machine actually does it faster than the first. So we know our answer is going to be less than 2.5, and we have actually a lower bound also. What if there were 2 fast machines? How long would it take? It'd take 1.5 hours. So we know our answer is in between 1.5 hours and 2.5 hours. We know it is. When you can do that with a problem, it's very useful to say, you know what, I know reasonable answers here. I know an unreasonable answer is more than 5. Doing something by itself takes 5. You get help, it's going to take less time, right? It's going to be less than 5 hours for sure. And definitely can't be negative. We have all these things we can use to make sure we get a reasonable answer. And then usually you get a reasonable answer, you can be confident you got it right. So here's what you got to remember here is that we're thinking in terms of jobs, right? Or work. What's work? Work, kind of like distance equals rate times time. You can say your work equals your rate times time. Or you can say the number of jobs that you do is the rate that you do them in times the time you take to do it. That's how many jobs you do, right? I can do... so anyway, that makes sense. So these are the things we got to keep in mind, all right? This is the kind of thinking. So first things first, we have machine A can stuff a batch of envelopes in 5 hours. So I like to... so I guess we could set it up like this. So let's do it like this. Let's read it one more time. Machine A can stuff a batch of envelopes in 5 hours, while machine B can stuff a batch of envelopes in 3 hours. How long would it take the 2 machines working together to stuff a batch of envelopes? So we are doing one job. And that's the important thing to remember. One job. And so we got here the amount machine A does, the amount of work, right? Machine A does, plus the amount of work that machine B does. Okay, we add those two amounts, and what do we get? We get one job. We get one. The amount of work they do together, which is one. That's the way the problem was set up. If it wasn't one, we could make, if it was like they're doing 3 jobs, they're stuffing 3 batches. How long is it going to take? We could put a 3 there, right? Anyway, so, but the way this was worded, it's definitely 1. So what's the amount of work machine A does? Well, it's the amount of work. So the work is the rate times time. So what is the rate and what's the time? Or another way to think about it too is that the rate equals the work divided by time. And this is the way I like to think about it. Because we have the rate. That's what they gave us. Machine A can stuff a batch of envelopes in 5 hours. So that's one batch. So the work is one batch. That's how much work in 5 hours. That's the time. So the rate is 1/5. So the amount of work machine A does is 1/5 times the time it's spending on the work. So the rate is 1/5. The time is T. We don't know how long it's going to take. That's what we're trying to figure out, actually. Plus the amount of work machine B does. Well, it does one job in 3 hours. So its rate is 1/3. 1/3 job, an hour, right? So you can also think about it like this. It does 1/3 of a job an hour. After 3 hours, it's done a whole job, right? So 1/3 times 3 is one job. So it makes sense because how long you do a job times the rate you do it, that's how many jobs you do. So anyway, there's, again, my long explanation, because this was very unintuitive. A lot of people want to put 5T and 3T. That would be completely wrong, and if you worked it out, you would see we wouldn't get the solutions we talked about. We get something totally different. So we have 1/5 T plus 1/3 T equals 1, because we know we're going to get one job. We're trying to figure out how long it takes to do one job. So now let's work this out. I don't like fractions. I'm not going to get a common denominator. I'm just going to multiply both sides by 15 times 15 times 15 and times 15. So I'm multiplying both sides by 15 because 15 divided by 5 is 3 and 15 divided by 3 is 5. So what I get is 3T plus, right here, this will be 5T equals 15. And that's a much nicer equation to work with. So I just got rid of my denominators. And that's an old trick. Now we can go ahead and solve this guy. But the hard part was getting what I had in orange there. That's the hard part. So now we have 8T equals 15. Divide both sides by 8. And we have the amount of time it takes them to finish one job working together. It is 15/8, which is going to be a decimal. It's going to be 1.875 hours. And if we wanted to be really mean, we'd say convert that to minutes, hours and minutes. But you know what? It's going to be fine for now. So that's how long it's going to take. Now, does that make sense? Is that what we talked about before? We knew it had to be more than 1.5 hours. Yep, it's more than 1.5 hours. And it had to be less than 2.5. It is less than 2.5. That's a very reasonable answer. That's probably right. I feel good about it. Very, very good. I like it. Now, I took my time on that problem, and it took 10 minutes. So I think I'm going to stop it there. This was just a work rate problem that we're doing. So, look at that. It's doing so good reading my handwriting. I have great handwriting. So anyway, until next time, enjoy doing math.